My topic this morning is all about alternating series, pre-chew, and rote test. So what is alternating series? An alternating series has terms that alternate with between positive and negative. It may or may not converge. So example, this one. As you can see, as you as you can see, there is an alternating na negative, then positive, then negative, then positive. That is what alternating series. So, this is one converges on the natural logarithm of 2. The summation of n sub 1 to infinite is negative 1 to the power of n plus 1 over n equal 1 minus 1 half plus 1 third minus 1 fourth plus 1 fifth equal in 2. This one converges on the natural logarithm of 2. Advanced explanation. To show why, first we start with an square of an area 1 and then pair up the minus and plus fraction to show how they cut the area down to the area under the curve y equal 1 over x between 1 and 2. Makita nato diri sa illustration na yung picture giunsa. So, the ratio test. Let the summation of n equal 1 to infinite a sub n be a series with non-zero terms. Let p equal limit of n which approaches to infinity a sub n plus 1 over a sub n. First, if 0 less than equal p or less than 1, then the summation of n equal 1 to infinity a sub n converges absolutely. So, kung ang 0 is less than equal to p, then less than 1. Mao ni ang converges. So, second, if p is greater than 1 or p equal infinite, then the summation of n equal 1 to infinity is a sub n. It is diverges kung greater than 1 siya or infinite. If p equal 1, kung equal 1 lang siya, the test does not provide any information. So, for example, for each of the following series, use the ratio test to determine whether the series converges or diverges. So, the given example 1 is the summation of n is equal 1 to infinity 2 to the power of n equal in factorial. So, from the ratio test, we can say that p is equal limit of n which approaches to infinity 2 to the power of n plus 1 over n plus 1 factorial over 2n divide n factorial equal limit of n which approaches to infinity 2 to the power of n plus 1 over n plus 1 factorial since n plus 1 factorial is equal n plus 1 times n factorial. So, p equal limit of n which approaches to infinity 2 over n plus 1 is equal 0. Since p is less than 1, the series is converges. So, number 2, or letter B. The example of letter B, the given is the summation of n equal 1 to infinity n to the power of n divide n factorial. So, we can see that is equal limit of n which approaches to infinity n plus 1 to the power of n plus 1 divide n plus 1 factorial over n to the power of n divide n factorial equal limit of n which approaches to infinity n plus 1 to the power of n plus 1 over n plus factorial times n factorial over n to the power of n equal limit of n which approaches to infinity n plus 1 over n to the power of n equal limit of n which approaches to infinity 1 plus 1 over n to the power of n equal e. Since p is greater than 1, the series is diverges. So, the given example of C is the summation of n equal 1 to infinity is negative 1 to the power of n times n factorial to the power of 2 over 2n factorial. Since negative 1 to the power of n plus 1 factorial times 2 divide times 2 times n plus 1 factorial over negative 1 to the power of n times n factorial to the power of 2 divide 2n factorial. N plus 1 factorial times n plus 1 factorial over 2n plus 2 factorial times 2n factorial over n factorial equal n plus 1 times n plus 1 over 2n plus 2 times 2n plus 1. We see that p equal limit of n to the power of 8 n plus 1 times n plus 1 over 2n plus 2 times 2n plus 1 equal 1/4. Since p is less than 1, the series is converges. So this one is example also of ratio test. Let's proceed to root test. Consider the series, the summation of n equal 1 to infinite a sub n. Let p equal limit of n equal 1 square root of n amplitude of a sub n. If 0 less than equal p, then the summation of n equal 1 is infinite. A sub n converges absolutely. Number 2, if p greater than 1 or p is equal infinite, then same ra siya sa ratio test. Pero ang katulo kining if p equal 1, the test does not provide any information. The root test is useful for series whose terms involve exponential, in particular for a series whose terms a sub n satisfy a sub n equal b sub n to the power of n, then n square root of a sub n equal bn, and we need to only evaluate the limit of n which approaches to infinity, b sub n. So here's the example. For each of the following series, use the root test to determine whether the series converges or diverges. So, letter A. The summation of n equal 1 to infinity n squared plus 3n to the power of n divide 4n squared plus 5 to the power of n. So, the solution, to apply the root test, we compute p equal limit of n which approaches to infinity n square root of n squared plus 3n to the power of n divide 4 n squared plus 5 to the power of n equal limit of n which approaches to infinity n squared plus 3n over 4 n squared plus 5 is equal 1/4. Since p is less than 1, the series converges absolutely. So, the example of letter B, example ni siya, pero akong giano nga mahimo ni ninyo og kanang ansiranan or try ninyo activity. Kining letter B, the summation of n equal 1 to infinity n to the power of n over ln times n to the power of n. So that's all. Thank you for watching.